Hello everyone, this is 𝐂𝐨𝐿 and today we are deep diving into system design of Google Drive. Google Drive के बारे में हम discuss करने वाले हैं. How can you design systems like Google Drive? If I ask you, if this question is asked in your interviews or you are thinking at your end only, right? Like how can you design storage systems such as Google Drive or Dropbox? Okay, we will jump directly into the functional requirements. When we say that we want to design Google Drive or Dropbox, then what kind of functionality we are seeking for. So first one is upload files. Basically, since this is a storage service, you want to provide a functionality so that files can be uploaded. Now the file can be of any type. It can be of let's say your MP4 file. It can be just your images in the form of PNG, right? So it can be any files, it can be text documents, it can be any type of files. This storage system should support all kind of files to be uploaded and then accessed later. Basically you can download the files. Another thing, like we are just taking this into consideration that the file size is up to 10 GB, but like there is no limit as such when you actually upload. If you have like premium version of Google Drive, then actually you will have storage more than 15 GB as well if you are subscribed to it. Similarly for Dropbox, if you are a premium member, then you can get access to more storage. So definitely it will depend on logically you will have the infinite space available, but you just have to pay it. So for like our reference, or like for our design discussion, we are assuming that our file size is maximum of 10 GB. Okay, so this is the first functionality. Another functionality we are looking for is the download files. Basically whatever you have uploaded, you should be able to download those files. Sync files across the devices. So assume a scenario that you own a laptop, okay, and then you have two phones. So whatever you upload here on this device should be accessible on other device as well as soon as it is uploaded there. So as you upload anything here, you should be able to see those, or if you want to able to view, or if you want to able to download, you should be able to do that. So basically we are looking for a sync feature. Anything which is uploaded on your personal laptop or anything you have uploaded on the mobile should be reflected or should be synced with other devices which you own. ठीक है, कि जैसे the Google account you have, the same Google account you use in the mobile as well as your laptop, so the file should be synced across the devices. Share files with other users. Definitely like it's like you will have to update the permissions of file, like who all users can access the file, right? As you upload the file, like you can give them permissions to edit the file or download the file or view the file. So similar kind of functionality we are looking for. Jumping into the NFR. NFR is basically your non-functional requirement. If you don't know what is functional requirement and what is non-functional requirement, there is a video in our playlist. Go check that out and all your concepts will be cleared out. कि functional का मतलब क्या है and what do we mean by non-functional requirements when we actually design the systems. So the first requirement we are looking for is this. Like if we talk about NFR, right, in general there are some basic NFR which are always taken into consideration whenever we design any system, such as availability, right? Like any system you design, it is designed for some customers, right? Okay, it is designed for some customers. Now if we are designing this system for some customers, we want this system to be available, to be used by those users, right? ऐसा नहीं है कि यार हमने सिस्टम बना दिया वो अवेलेबल ही नहीं है, तो like how they will actually use it. So if you are using Google Drive, this Google Drive should be able to serve the customer request. So this is what we mean by availability. So if we talk about another NFR, which is scalability. Now scalability as in like as your user base grows, ठीक है, कि like let's say right now you are supporting 10 million users. As it becomes 100 million, your system should be scalable. Enough to handle this growth. ठीक है, as your user base grows, your system should be scalable to handle that growth without impacting the performance. ठीक है, जब हम scalable बोलते हैं, we need the same kind of principle, same kind of what we say, same kind of performance. Like your performance should not be degraded. This is what we mean by scalable. Consistency. This is a kind of important requirement here. Why? Because any file which is being uploaded, so here we mentioned that you had multiple devices, right? Now if you have multiple devices in this architecture, then what you need that anything which is uploaded on any other device, right? Anything which is uploaded on one device should be visible to other systems as well and in a consistent state. ऐसा नहीं होना चाहिए कि एक file which is uploaded on this system, it is visible something else here and it is present something else here, right? Or the simple example you take it this way, that like there was one file.mp4. Okay, you uploaded a new version of it, and as you upload the newer version of this file, this newer version should be reflected on other device as well. यहाँ पे ऐसा नहीं होना चाहिए कि आप अभी तक पुराना वर्जन देख रहे हो. So basically this is what we mean by consistency. Another thing is durability plus reliability. Again, so this is your storage system, right? This is your storage system. So you don't want any scenarios कि this specific file which is file.mp4, if it's uploaded by the user on our system, it should not be lost. ठीक है, it should not be lost. If we are talking about a storage service, now user is not bothered about if you are replicating this file or like whatever you are doing at your end. You have to make sure that your storage service which you are designed is reliable enough. ठीक है, या फिर आप डेटा को ऐसे रेप्लिकेट कर रहे हो, या फिर एनी मैकेनिज्म्स यू आर अप्लाइंग, द डेटा शुड नॉट बी लॉस्ट. ठीक है, डेटा एक बार अपलोड कर दिया, अनलेस इट इज डिलीटेड बाय यूजर और अनलेस इट इज मॉडिफाइड बाय यूजर, इट शुड रिमेन सेम, इट शुड बी देयर इंटैक्ट. समझ गए बात कि मैंने एक बार स्टोर कर दिया, वो यहाँ पे रहना चाहिए, चाहे तूफान आए चाहे आंधी आए, कुछ भी आए, इट इज आर ड्यूरेबिलिटी व्हाट विच वी आर प्रोवाइडिंग. Got it? Now another is large file download upload should not fail on network disruption and should be resumable. So what we mean by this is that as you upload large files, let's say your file size is 10 GB. Now you don't want to be in a scenario that your 90% upload was successful, and once your 90% upload was successful, your internet went down. Okay, this network disrupted, your internet went down. So you want a functionality that as my internet comes back, as my network is restored, this file upload should resume after 90%. ऐसा नहीं होना चाहिए भाई कि मैंने 90% अपलोड कर दिया था, इंटरनेट खराब हो गया एंड उसके बाद you will have to upload the file again. ठीक है, so we are looking for a functionality that your large file should be uploaded, downloaded, should not fail on network disruptions and it should be resumed कि जहां तक हो गया था उसके हम आगे बढ़ेंगे. Now let's talk about estimations कि any assumptions we are taking, right? These like all the estimations which I have considered are based on some kind of assumptions. Okay, so let's talk about the basic numbers. Okay, so सबसे पहले अगर हम बात करें number of users की, so number of users are 1 billion. Okay, so if we say number of users are 1 billion, like these are numbers basically I looked on from internet. I am not sure they are correct, but they should be, like seems like a huge number, and they were from, like, not specifically from Google documents, but they were from internet, so not highly reliable, but we will go ahead with this, and that's why I added a note here that these are based on assumptions, like whatever we are discussing here. Okay, so the number which we are discussing here is like what is the number of active users we are looking at. So if we talk about the daily active users, it's 10 million. Okay, so storage allowed for user, like for a user, what storage we are allowing, it's 15 GB per user. Got it? So लेट्स टेक ए स्टोरेज फॉर 2 बिलियन यूजर्स. ठीक है, कि हम थोड़ी सी स्केल का माइंड में रखते हुए कंसिडरिंग यूजर ग्रोथ, व्हाट इज द टोटल स्टोरेज रिक्वायर्ड. सो 2 बिलियन इंटू 15 GB, इट्स अराउंड 3 किलो पेटाबाइट्स. ठीक है सर, सो दिस इज द टोटल स्टोरेज वी आर लुकिंग एट व्हेन वी एक्चुअली want to design the system. So definitely whatever storage solution you are choosing, ठीक है, मतलब जो भी आपकी यहाँ पे कुछ सर्विसेज रहेगी, they will end up dumping this data to some kind of hard disk, right? Some kind of hard disks. So these hard disk or these kind of storage, whatever you are using, it should be able to support this scale. ठीक है, कि user growth, अब यहाँ पे like we took this 15 GB as a upper limit, but as I mentioned that users can buy a premium subscription and this limit will not hold true, but on an average, हाँ ठीक है, on an average not all users will use this 15 GB as well. So we are assuming that for all users, for all 2 billion users, we have 15 GB of storage, which comes to this number. Assuming each user uploads 2 files per day of 100 KB. Okay, so storage requirements by that by that analysis will be this number. Okay, so this is total storage per day. Got it? Now TPS. So TPS, again, like we mentioned that 10 million active users into 2, again this is our scalability number कि अपना कुछ peaks रह सकती है per day. So if we talk about per second TPS, this is 232 request per second. So this is a kind of average number, right? If we talk about file upload, right? If we talk about file upload, now these requests are not something like key they are like your server got the request and the request is served and response is returned. These requests, like in the context of our storage service, don't work like that. How they work? We had two use cases, right? One is upload file, then download file, upload download, right? Upload download, right? And then one is sync feature. So if you see in all these features, we are kind of maintaining a long-term connection, kind of a persistent connection, or a long polling wala type of connection. Why? Because if you're uploading, right, your upload will carry on for a certain time. If your file size is huge, it will carry on for a certain time. So per second wala jo ye hai kind of average number hai. Okay, and similarly for sync, if you want your systems to be in sync, if you have like 3 devices and if you want these 3 devices to be in sync with each other, you want these devices to be connected with our storage system. So that will also add to our total TPS which our system is serving. Now let's move to our high level view of system. Okay, on a very 10,000 feet view, how does our system look like? So this is your handsome user Mandeep. As usual, Mandeep अपना क्या कर रहा है, Google Drive system को use कर रहा है. He is uploading some files, he is downloading some files, and also Mandeep also owns a phone, Mandeep also owns a computer. ठीक है, so all the files which are uploaded here, let's say file.mp4, this file should be available on this phone as well and this computer as well, which is synced across the devices. So this is how our very क्या बोल रहे हैं हम 10,000 view of our system looks like. Now let's deep dive into it more. Okay, so specifically starting from how does upload work, कि जो हम फाइल को अपलोड कर रहे हैं, दिस यूजर मनदीप इज अपलोडिंग सम फाइल्स, हाउ दिस अपलोड फंक्शनैलिटी लुक्स लाइक. सो इफ यू टॉक अबाउट स्पेसिफिकली अबाउट रिक्वायरमेंट्स ऑफ अपलोड, व्हाट काइंड ऑफ रिक्वायरमेंट्स वी आर लुकिंग एट. फर्स्ट रिक्वायरमेंट इज it should work on devices with different network types. Okay, so when we say different network types, what we mean is this is your mobile internet, right? This is your mobile phone, this is your computer. Now it could be possible that this mobile is using mobile network, right? This mobile is using mobile network again, and this computer using Wi-Fi 5G wala. ठीक है. So if you talk about the network speed will highly vary. So your system should support all kind of network speed. ऐसे अपना system, like we don't want our system कि वो expect करे user से कि the 10 GB file should be uploaded within 10 minutes, right? For some users it could be 5 minutes, for some users it could be 1 hour. Now our system should be able to support all these kind of users. Our system should not create any differentiation based on network type कि ये network type है तो मैं ये करूंगा, ये network type है तो मैं ये करूंगा, right? So this is what we mean by different network types. Minimum possible network bandwidth usage. Again, when we say the users are uploading the files, we don't want to consume all the data of these users. We want to consume the minimum bandwidth. ठीक है. Another one is upload should not fail due to internet connectivity. This actually we already discussed, right? Our requirement was in the NFR we discussed that the large file or whenever you upload large files or whenever you download the large files, it should not fail due to network disruptions. ठीक है. Whatever the condition with network, the download or upload should be resumed by this storage service, and then it should continue from wherever it was left off. So these are the requirements when we actually talk about upload. Now how can we resolve certain kind of issues, right? So if we talk about this third specifically, or other, like we will also discuss the other ones, but if we talk about the third specifically, in general it's solved by breaking large file into smaller chunks. ठीक है. It is used, it will help us. How it helps? If you watched a Netflix video, we created one video on how Netflix how Netflix uploads the content, okay, or how content is uploaded on the how content is uploaded on Netflix servers, right? So in that discussion we discussed that a large file, right, this could be in TBs. Assume a file which is shot in 4K video file which is to be stored on Netflix servers, right? So for processing of these large files, this file is basically broken down into smaller chunks. Whatever's the size we specify, let's say 4 MB, it is broken down into smaller chunks and then it is processed in parallel. Similar approach we are taking here. So what we are doing, we are breaking this large file, let's say it was 10 GB, okay. This 10 GB file will be broken into chunks of 4 MB each. Now once this file is broken down into each chunk, these chunks will be uploaded in parallel or like sequentially, whatever approach you are taking. Parallel will definitely speed on the upload functionality or the download functionality. It will basically speed up, right, because you are downloading or uploading the chunks in parallel, okay. So your client, the client which you have on your web or the Google Drive client you are using, it should break the file into multiple chunks and then it can be processed in parallel. So you can upload the chunks in parallel. Failure only require uploading remaining chunks. Definitely it will serve a requirement in case our network disrupted after 90% of chunks uploaded, then those chunks already have reached the server. So once network resumes, you can upload the remaining 10% chunks. So this issue is handled by. Also it helps in versioning, easily figure out the diff. So we will discuss one example around how you can do it actually by the help of chunks, but it will help if let's take a simple scenario. Like before moving forward, let's take a simple scenario that you have to compare two 10 GB files, right? And another thing is you have to compare two 4 MB files. Which one is easier, right? Which process is it? It's definitely easier, right? So if the file size is small, it's easier to figure out where is the issue or like where is the actual change which has happened. So it will basically help in maintaining the versions. Okay, and specifically to maintaining the versions, we will create a separate video where we will be discussing the design of Google Docs, where this functionality shines. Like there is a huge requirement of such kind of functionality, but I'm just giving a basic gist. Now let's move on to our complete design of a system. How does our system works or how does it look like? We sometime back we discussed a very high level view, 10,000 feet wala view, ki how does our system work. Now let's deep dive into specific components. So if you upload a file, how does it work? If you download a file, how does it work? So let's move into that. Okay, so let's start from our user device. So user device, let's change the color of pen. So we are here with crazy pink. Okay, so you have a Google Drive client, right? You are either using a web application like on a website, or you are using Google Drive's application on mobile or like your iPad or any device which you are using. So what you do, you upload one, like this is the basic structure which I created: file 1, file 2, folder 1, then you in folder you have multiple files. So what you will do, this Google Drive client, what it will do, you want to upload this file 1, okay. So if you want to upload this file 1, this file 1 is broken down into chunks. Got it? We will discuss this complete architecture again later. Let's discuss that first. So if we talk about Google Client Service, right, it has file chunk created which will create the chunks. It has a file sync component. So like any updates which you get from another devices, right, it should sync the local store with those changes. And you have also a local DB which persists the file locally, okay. So create the file into chunks. It is handled by this. For file upload with specific chunks to be uploaded again, taking hash and Merkle tree uses. So let me give you quickly a gist around it. So what you can do, if you want to upload a specific let's say the file was let's say changed a little bit, okay. You have this file of 1 GB. Let's say there was a small change in this file here, okay. Let's say there was a small change in this file here. What you can do, either you upload the file completely again, like you broke them down into, let's say 10K chunks, and you uploaded the file again. what you can do, this file chunk creator, what it can do additionally to optimize our upload functionality, what it can do, it can figure out in this specific file what is the specific component that was changed, what was the specific chunk that was changed. If we are able to figure out that, you only have to upload that, you don't have to upload the complete file again. So how can you do it? One such way is, you can take the hash of those chunks, right? You can take the hash of those chunks, and then you again keep on taking the chunk hash of those chunks to figure out how does it, like I will not go to complete deep dives. We actually discussed this in another video of Dynamo, where we discussed around Merkle trees, how anti-entropy process works in Dynamo, like basically if there are any unsynchronization in the replication, so how does it handle it. Basically uses Merkle trees. Merkle trees helps you to specifically identify कि कौन से chunk में change हुआ है, and then replicate that chunk only. So similar functionality we are specifying here. So you figure out basically which chunk has a change, and that specific chunk is uploaded again. So we are clear with the Google Client Service. Now let's move to another component. So once you have figured out that these are the chunks which you have to upload, you have a file service. Okay, this file service is so you basically pass on these chunks. Got it? So you can assume this as a HTTP request. Okay, so what you are doing on this HTTP request, you are passing on these chunks, and this file service, what it's doing, it is doing two operations. One is that it stores the chunks into S3 storage. Now why we have chosen S3, this is again a point of discussion. If we talk about Dropbox, right, Dropbox started earlier with using S3, and then they later on moved to their own personal storage, some kind of storage, their own data center. But we are like S3 is scalable enough to support our needs. Okay, and Google Drive definitely don't use S3, because S3 is service which is provided by Amazon. So I believe Google has its own proprietary software or storage service which it uses. But for our design discussion, let's assume we are using S3. So S3 is your object storage basically. Okay, S3 is your object storage where you can upload any kind of files, and then you can access them as per your requirement. Got it? So this file service has one functionality of uploading the files to uploading the chunks to S3 storage. Another thing is like where this chunk was specifically updated, right? Where this chunk was specifically updated, or where this chunk was specifically stored. We need to keep that metadata. So as you require them, you should know, right, ki, where this chunk was properly stored. And if you want to combine those chunks into a single file, later on, let's say the Google Drive also provide a functionality to view the file, view the video in Google Drive client itself. So for doing that purpose, for viewing the file completely, you can't keep on sending the chunks, right? You have to figure out that these chunks, these specific chunks, these 100 chunks combinedly make a single file, and in this order we have to combine them. So for that purpose, we have another component. So what we do basically pass on these messages to queue. Why we are passing it to queue? So that your multiple clients which you have can use that data, and it, like if they in future, if application grows as well, if there are number of applications which are growing, this message queue is like they can basically subscribe to the topics on any updates which is publishing, and that service can use it. And another thing is that it don't require to call on a different APIs again and again, right? So what it do, it passes all the information to a message queue. Now this, we have two functions here. One is, we mentioned that we need to store some information around the chunks, like where they are stored and how they can be combined. So for that we are using a metadata DB. Okay, for that we are using a metadata DB. So this metadata service handles that. Another thing is, you have a sync service. So as the metadata is updated, the sync service holds the responsibility to update other users. Okay, so basically it publishes those notification to a message queue, and it can pass on that information to these user devices, other user devices, so that these user devices can download those chunks to their local copy. Okay, so these user devices as well runs a local Google Drive client on their end, right? So these local Google Drive client can upload the file, can download the file on their local storage, and then user can view them or like any other functionality they require. Got it? So this is like a very what we say, not a very high level, not a very low level, but kind of a in between design which we have discussed. Now if we talk about this design, right, basically this metadata keeps information about chunks and the sync between user devices, so it has to keep this information basically कि कहाँ पे वो sync हो गई है data, ठीक है, और कौन से devices हैं for this particular client, and then basically also update the metadata about the chunk information. Now what issue can this design have? One problem: what if only file path is updated? What if a file path is updated, the client application should not directly interact with metadata service. So in this case, should directly interact with. So in this case, how the architecture, or like how the invocation calls happen? If any file which is uploaded, first you talk with the file service, and then its file service upload the st storage. Let's say in some scenarios, only the file path is updated. This file was moved to, let's say, this folder, so you don't need to update the file itself. Like you don't have a requirement to upload the file again to file service. Like it don't have the requirement to be stored to S3, right? So it can basically figure out, this client can basically figure out that there was no change in the file, basically like how we discussed, right? We discussed that design kahan pe hai bhai? Where is our Google client? Yeah, so we discussed that you can actually figure out what was the change. So in this case, there was no change in the file, only the metadata of the file was uploaded. So we need some mechanism that this Google Drive client should directly integrate with metadata service, right? Directly integrate with Google metadata service. In this design, we have a file service first, and then from file service, it basically pushes the notification to a message queue, and that from that message queue it is finally uploaded to metadata service, right? So it creates one problem. How can you further optimize it? Let's optimize it. So event driven architecture. Again, this component specifically we have to discuss this in the last video. Actually, in the last video where we discussed around the WhatsApp architecture, we discussed one approach around if we can use a message queue here. We can definitely use a message queue instead of using a HTTP request directly where the files are uploaded. What it can do, you can Google clients can upload the files to a message queue, and from the message queue this file service can poll the files, and then it can perform the other operations. So that will be more scalable approach. But so this is one component. Anyway, this design breaks our basic connectivity or basic design principle due to this issue, because it is not serving the complete requirement. So let's move further on how can you improve it. So on event driven architecture, since file upload is not latency sensitive operation, a mechanism can be preferred, right? Like whatever I mentioned here, you can create a queue here, basically operation queue. Whatever it is being uploaded is passed on to queue, and then file service can download the chunks from there. Clients to uploader service, sync service to clients. Like so, in this approach we have already used a message queue here. This also in here as well you can use a message queue to further scale your system. Now architecture improvements to further update our system. Okay, so let's create a message queue here. Okay, now as this Google Drive client upload a files to metadata file service, it will be stored to S3. This is one architecture we already discussed, right? Now another thing was, like, what was the issue? Google Drive client should upload, like, inform the metadata service on what was the change being done. Like let's say the file was earlier present in folder 1 and then it was moved to folder 2 कि अपनी ये file.mp4 है, earlier it was present on f1, then it was moved to f2. So only metadata of this file change, we don't have to upload the file again, the file is already present in our S3 storage. So in that scenario, what it can do, it can only update the metadata service. So we don't require this functionality. Not require this functionality as in we don't have a requirement to upload the file again. So what it can do, this Google Drive client can identify what specific services it has to call, right? It has to call. So metadata can cause, let me read quickly what I have written here. Directly updating metadata DB can cause issues if other user already uploaded another version. Okay, so let's discuss this complete flow, and then we will identify what if there can be any issues with this flow as well. Okay, so let's say this was user 1. Okay, the user 1 has access to the file.mp4. this file is only the path is changed. Okay, so this metadata service, you will inform this metadata service that this is the operation being done. But before that operation being done, before the metadata service is updated, it has to confirm, the Google Drive client on a user one has to confirm that this file was not modified by any other client. Okay, this file was not modified by any other client. If that is being done, then it has to gracefully handle that. So one way could be to basically figure out this sync service has a responsibility of doing this, right? So this sync service pushes the updates about specific files. So if we get the information about this file being updated by another client, so that file should be downloaded before, or like any changes which is being done to, and further the metadata should be updated. Okay, so this is how you can resolve this ambiguity in this design. Now what if the client list is huge? It can cause a fan out problem. We will quickly discuss this. So this whatever I have written here is that you have to basically get on the file, like update first before actually updating the metadata service. So first your sync service is responsible that it is sending all the notification to me, and according to those notifications I will identify that this file was not updated by any other user. Got it? So another issue which could be caused in our issue with the fan out problem. Okay, so what is the fan out problem? Fan out problem is that what if there are 10k users here? What if there are 10k users here? So this sync service has to inform all those users, right? If this file was accessed, if this file has to be accessed by multiple users, lot of users in bulk, 10k users is one example. What if this is 1 million? So in these kind of scenarios, we will have to specifically handle, right? So in Google documentation, I read somewhere that for Google Docs specifically, it easily supports up to 100 users. Easily supports up to 100 users which can update and share, like, or like edit the document concurrently. Right, so this was one way to go about it. So either we limit the number here, right? So let's say you have what we say if you have a, क्या बोलते हैं उसको यार, मतलब आप कर सकते हो, you can do it, like you can definitely share the file with 1 million users, but it will come with some cost. So our system requirement should define that if the user is huge, there can be some lag in the way the file is updated to all the clients, right? So we had this requirement of strong consistency. So we can take a leeway there कि वहाँ पे we will not be able to strong consistency, but we will be able to provide eventual consistency if the number of users is huge. Another way to go about it, to keep a persistent connection with all the users, right? So as and when there is update coming, you update those users as well. Similar to our messaging platform where you maintain this persistent connection with all the users. So according to that, you can update all the users to which our service is connected. Got it? Another thing is conflict handling. So we mentioned that there can be conflicts when multiple users access the file, right? So either you use last write wins, ask user for which version to keep. So again, like this specific requirement we will be discussing in Google Docs, like how can you how multiple users can concurrently edit the files, and how can you handle the conflicts. Okay, so these are the general recommendation which can be used, but there should be some solution built in system as well which automatically handles this. Okay, so Google Client Service, we already discussed how it works at the client end. Now let's discuss some further optimizations in this current design. So in here, first point is, as files are divided into chunks, there are huge chances that chunks of different users are same, right? This can happen. Again, we discussed this in our WhatsApp video as well. There is a potential problem that same file is uploaded again and again, right? This can easily happen in an application such as social media, where the same file has to be uploaded again and again. So same file is shared by multiple users. So since this file is broken down into multiple chunks, if the chunk resembles to a already uploaded chunk there, can you optimize the space somehow? So this is one huge requirement right? This one huge requirement. If you can do it, then you can potentially solve a problem of storage space, right? You are not uploading the file again and again to S3. You are basically identifying, right? You are identifying that this file was already updated, so you only have to update the metadata. ठीक है कि ये यूजर भी इस चंक से एसोसिएटेड है, right? You only have to update the metadata. You don't have to update or you don't have to upload that chunk specifically to S3. So you are optimizing on the space. One way to go about it, like to use a hashing algorithm, right, to see in our metadata that if this chunk is already present or not. If it's present, then definitely don't upload it again. If it's not uploaded, then definitely you can do it, right? The second point is, instead of uploading files to S3 via file service, can we store files to CDN and then move further? This this is in the context that if the file is to be shared with multiple users, right? If this file has to be uploaded, shared with multiple service. So our general architecture is that the file goes to a queue, right? This file goes to a queue. This file goes to a queue, and from queue it is updated by store to file service. Then it is moved to S3. It publishes some kind of notifications, right? This is your sync service, and then sync service pushes the notification to other devices, and these other devices can basically then get the file from our S3, right? Get all the chunks. So this can be a lengthy process here. This can be a lengthy process. So can we somehow store this file to a CDN first, right? So that these users can download the file from here directly, right? So to start with the design, definitely to start with the design, we don't need it to keep all, like we don't need all the data on CDN first of all, right? You don't need all data to be present on CDN. You only want the data which is frequently accessed. Okay, so as you start the design, then you don't have to think about the CDN putting in between. But as you scale and as you figure out that there are some files in our storage system which are frequently accessed, right? That happens in the Netflix, like we discussed that similar scenario in a Netflix, where let's say this movie has to be released tomorrow. So this movie will be accessed by multiple users. So we beforehand place that movie near to those users. So if you have certain that kind of requirement, then we can think of this kind of solution. But if not, then we can directly skip it and then further evaluate in future if or any such requirement comes to, and if there is a requirement to place the contents near user as well. S3 is already scalable. You can replicate the data across the regions as well. So it's already scaled well. Then you can evaluate if there is a requirement to put that data in CDN as well, right? Because you don't have specific, in case of storage service specifically, you don't have any users patterns, right? The storage service is not like, it's like a user based. User uploads the file and then they access it. It's not like we are uploading some files and then users has to access that, so that you can push the content to CDN and then from there users can fetch the content. So we don't have such scenario because we can directly skip the CDN. I hope you got my point, what I'm trying to explain. If not, comments करके बताना यार, and we will try to discuss it and I will try to explain it more. So as we discussed, this can potentially add extra complexity, and definitely we don't need it. Now another thing is updating all clients for any update in file. So if there is any update which has occurred in file, how can you update it? One mechanism so this is extension of what we discussed in our WhatsApp video. This comes in handy whenever we have a requirement that multiple users have to get access of some information and they has to be in sync, right? The users has to be updated in real time. So one way is that all these users maintain a persistent connection with our system. This is a front-end service which I have created. It helps it performs well with the help of our connections DB, where you are updating like which particular user is connected to which thread, and by that it can use that information. Got it? So there are two ways to go about it. One is that you use long polling. Okay, so if there is any update, so basically you establish a connection and then waits for, let's say, 100 seconds. So if there is any update, the server will return response. If there is not, then you can terminate this request and then again create a connection. Another way is persistent WS connection, WebSocket connection basically. So in this design specifically specific to Google Docs, not Google Docs, specific to Google Drive, we should not require a persistent WebSocket connection. We can definitely evaluate it, but we can think of any of the solutions which can be used. Like either you use long polling if you want the users to be in sync, or either you can maintain a persistent WebSocket connection, right? Okay, so this is the way to go about it, and definitely I will recommend to watch our WhatsApp video where you will get the sense of this complete design, like how this design helps to keep the users in sync for whatever is happening in the system. Let's say two users, so it's similar to that only, right? The two users are trying to interact with the service and sending some notification. It has uploaded file, so this file has to be sent to this user. So the above architecture is similar to, okay, this is what we discussed, and we will scale it further on Google Doc. On if the multiple users are working simultaneously on a single file, then how can you evaluate it? So this is all about our Google Drive discussion. How can you design systems such as Google Drive or Dropbox, and then we will be discussing next around Google Docs or any other system. So you can definitely let me know in the comment section which more systems we should explore. If you are not yet subscriber of the channel MsDeep Singh, so consider subscribing. I keep on making content around distributed systems, system design, and then cloud, so you learn more about everything. तो हम मिलते हैं यार अपने नेक्स्ट वीडियो में, तब तक के लिए स्टे सेफ, टाटा बाय बाय।